What is the common denominator going to be for this one? V minus 4. So everything, we're not making everything have the common denominator. We're actually going to try to get rid of the denominators by multiplying by the common denominator. So everything's going to be multiplied by V minus 4.
I have a question.
Yeah.
Can you take a 7 out?
You could, but factoring at this point is not helpful.
Okay.
So you could, but not necessary. Really at the end, it's more necessary to see if it actually reduces. Okay, now we don't actually have to multiply all these by V minus 4 because they're just going to cancel out. But the first term, nothing reduces, so it's just 1 times V minus 4, which is V minus 4. Going to add the like terms together. So I have V's on both sides. So Reagan, do you know what I'm going to do now? Okay, now this is where we were having issues. Remember what comes next? Right, you want to get V by itself. So if V is on the right, we want to get rid of this stuff. Yeah. This looks like it's a mess. So, because 36 does not divide by 7. Okay, and remember, we can't use an answer that makes the denominator 0. So in this case, V cannot equal 4, which is definitely not what we got, so that's okay.
What do you do if you do this?
Well, whoops. You just throw it out. It's possible there's no solution. Sometimes these kinds of problems get 2 answers and you might just have to throw one of them out. I didn't really look at the answer sheet. I'm assuming one of these.
12, 5, 0.
Okay. So she says, because I said she got 0 on 12. Is that
I
a...
got negative 5.
Okay. I'm not sure yet. Let me look at it. Should get 4r equals negative 5. Yeah, Avery got it right. Okay.
Huh? Yeah, I think I wrote that down.
So you should have got r minus 4 equals 1 plus 5r. Did you get that? After you cross stuff out.
No, I'm still getting 0. What did I do?
Did you get r minus 4 equals 1 plus 5r? Did you get that?
No.
So if you multiply by 5r in the first 2 terms, the 5r's just cancel out.
Yeah. And 5r at r minus 4 equals r minus 4.
This is the 1.
Don't you have to change it to 5 r?
No. You're multiplying by 5r, which will just cancel out what you multiply by.
But don't you have to multiply with that one too? Did you say yes or no?
Yes. So this one 5r cancels out this one.
Oh, I just asked. Oh.
It's 1 plus 5r, right? Alright.
What's the answer? Negative 5 over 4.
What's the common denominator on 13? 3x. So these are kind of easy. Maybe a little bit too easy. Okay, so the 3x's will cancel out. That that numerator does factor, but factoring at this point is not helpful. All right, there is something new on this problem. New to this lesson, not something we haven't done. Hey, put that away. What's different about this problem? It's got an x squared. How do we solve, it's called a quadratic equation. How do we solve quadratic equations? Well, eventually. First, we need to move everything to one side and then see if we can factor it, right? 3x minus 5x is negative 2x. So I'm going to subtract x and add 6 so that everything on the right is gone, so we just have a 0. All right, yeah, so this one should have 2 answers. So what multiplies into 18 that we can add to get negative 3? What multiplies into negative 8?
Negative 6 plus 3.
Negative 6 and 3. So that multiplies to negative 18 and it adds up to negative 3. So what values of x would make these factors equal 0?
6 and negative 3.
6 or negative 3. Okay. Is either of these answers a problem? Okay, what's the only x value that will not work on this one?
Negative 3.
No?
No. No.
Ze- 0. 0 would be a problem because 3 times 0 is 0. But we didn't get 0, so we're still good. Put a lot of ones on this assignment. Okay, this one will be a little bit more work than the last ones. So what is our common denominator going to be for these two? What is n plus 1 and n plus 8 both go into? No. They both go into whatever n plus 1 times n plus 8 is. So we're going to multiply every term by n plus 8 n plus 1. So in the first, n plus 8 and n plus 1 are just two totally different numbers. I don't know what they are, they're just two different things. So you just need to multiply by both of them. In the first term, the n plus 8s will cancel out. So we'll have n plus 5 times n plus 1. In the middle term, nothing cancels out because there is no denominator. So we just have 1 times that stuff. So we just have n plus 8 times n plus 1. And on the last term, thankfully something cancels out. The n plus 1's cancel out, so we just have 6 times n plus 8. Ooh, that looks like a lot of work. So what do I have to do here to simplify all this? What kind of simplifying it?
Well, FOIL.
FOIL. So, 2 terms times 2 terms, that's FOIL. I'm going to kind of do the fast forward version. 1n plus 5n is 6n. 5 times 1 is 5. 1n plus 8n is 9n. 8 times 1 is 8. Distribute that. Alright, well, this does have n squareds. But what's going to happen with these n squareds?
Cancel.
If I subtract n squared on both sides, well, that's kind of good news because it gets rid of it. So this is not a quadratic equation anymore, it's just an n, just one variable linear equation. So my right side is, I'm going to clean it up a little bit, 15n plus 56. So I'm going to subtract 6n. And then what, Reagan?
Minus 56.
Right, that's another mess. This doesn't work out very well. It doesn't divide by 9, but that does reduce because 3 goes into both of those. So divided by 3, you get to that. And that is not going to make a denominator 0, so that is the answer.
What if both the n squared and the n cancel? Oh wait, well.
Well, it could
Oh,
be.
wait.
I don't think that's going to happen on this.
No, I must have done something different also. Or I just blocked.
If it did happen, then the answer could be like infinite solutions or no solution. But
I think I'm just.
I don't think that's going to happen today. Okay, so need to find the common denominator, what I need to multiply everything by. There's something a little bit different. This denominator is a little more complex than the other ones we've seen. So what can I do with this denominator? No. Well, how can we factor it? Yeah. Okay, an x comes out. So we take an x out, and yeah, we're left with x minus 5. So, between my two denominators, what's my common denominator going to be? What do they both multiply into? Okay, x is what goes into them. If I just try multiplying everything by x, is that going to cancel everything out? No, it'll just cancel that out. I need to multiply by x, x minus 5. That's what x and x minus 5 both go into. You need to use, when you're finding the common denominator, you need to use everything. So we need to multiply by x and x minus 5 on all of these. So in this first term is the easy one because everything cancels out. So it's just a 1. On the second term, just the x's cancel out. So I have x plus 7. Whoops. Minus 5. And on this one, nothing cancels out. Whoops, that's not an equal, that's a minus. Okay, there we go. Looks kind of like the last one, a little bit simpler because there's only one FOIL. So it's minus 5x plus 7x minus 35. Distribute that guy. Okay, well, this is an x squared problem. So it's a quadratic equation. So I'm going to move everything, since x squared is negative on the right, I'm going to move everything to the left so that it'll be positive. Let me clean this up a little bit. X plus 2x is 3x. So plus 5x is 8x. Okay, I'm going to move everything to the right because x squared will be not factoring. Did I make a mistake? 9 and 4, 6 and 6, 3 and 12. Did I copy it right? Let's start with that. X plus 7 minus 1. 8x minus 35. 2x. Oh! I don't know if I didn't write it or maybe the board screwed up. I'll blame the board. We'll go back to the video, see if it went. That was supposed to be an x squared, x times x. So, never mind. In this case, x squared minus x squared will go away. So that does make it easier. 5x plus 2x is 7x minus 35. These are all messy, aren't they? So I'm guessing the evens are pretty messy too.
Yep.
All right, uno más. So I noticed that the first denominator is p squared plus p. What should go through our brains if we see p squared plus p?
Take a pee out.
Take p out. All right, we can take a p out. And if we take a p out of p, we're dividing it out. P divided by p is 1. So both of these turn into p plus 1. I thought since the boys weren't here, I'd get away with it, but apparently not. You are not more mature than the boys. Okay.
I was.
All right. So what is our common denominator?
P plus 1.
P plus 1. You guys are fired. All right. Let's go red. Contrasting color. So I'm going to multiply everything by p plus 1. Still funny, yes. So on the first term, that all just cancels out. We're left with p plus 5. On the second term, same thing. It all just goes away. It's left with the 1. And on the last term, only the p plus 1 cancels out. So we're left with p times p minus 6. This won't be... This one will be a little bit harder. Okay, so I distributed the negative p. I'm left with a p squared, and there's nothing that'll cancel out on this one. So this one does look like another quadratic equation. So I'm going to move everything to the right. So I'm going to add p squared, I'm going to subtract 6p, I'm going to subtract 1. Yes, because the factoring trick only works if it says equals 0.
Can we do quadratic formula?
You can do quadratic formula, but it's usually just quicker and easier to factor. So sometimes you have to use quadratic formula, but they're not going to be that mean to us today. So what multiplies into 4 that adds up to negative 5?
Negative 4 and 1.
Good job. Negative 4 and negative 1. So what p values would make these factors equal 0?
4 and 1.
Right. Okay. Does 4 or 1 screw up any of our denominators?
No.
No. The only thing that wouldn't work is negative 1 or 0.
Negative 1, 14, and 20.
Have you actually tried 20? No.
Yeah, well, no, I took stuff out of it.
Okay. On 14, did you take an X out of
No.
the middle?